now I'm going to show you how you can add existing models to PLP. So as normal, you need to have your connection details, and you'll need to have a string that points to your common data model database schema, and you need to have a string that points to the database schema that has your cohort database schema. But the next thing when you're adding existing models is you're going to need a model table, which you see here, a covariate table that we see here, and an intercept table that we see here. So I'm just going to explain what all of these three tables actually do. So the model table is going to have, there's only actually 3 columns that you need, but I've added in an extra column just to make it a bit easier to understand. So the 3 essential are your model ID, your model covariate ID, and your coefficient value. But I've added in a covariate name, so the ID is giving you a unique ID for the covariate. So you can think of this corresponds to some sort of covariate. So it could be an age range, it could be a type of condition or some drug. So there's a name here that corresponds to the covariate ID. So if we look at this model table, I've added in there's one model here, so it has a model ID 1. So this means that this all corresponds to model number 1. So if you were doing a model for example, like CHADS-VAS, that could have a model ID 1, and if you had another one, the CHADS-2 score, that could be model ID 2. So you could actually have both models represented in this data frame. But I'm just going to give you an example of doing it with one model. So now I'm just going to show you this view model table because it'll be a lot easier to see what it means. So the essential columns are model ID, model covariate ID, and coefficient value. And this is basically saying that for this model covariate ID here, we're going to define effectively a concept set later on, but this corresponds to being aged 50 to 54. And this has got a coefficient value of 1. So if we're doing a logistic regression or a score-based model, we're going to see whether they had it times by 1, and then if it's a score that will be added to some other covariates that you have plus the coefficient value, or if it's logistic regression, you'll do the coefficient times whether they have the covariate summed up and then do some linear transformation. So then the model covariate ID number 2 corresponds to type 2 diabetes condition long term. It says coefficient of 1. Model covariate 3 is type 2 diabetes condition group long term. Now, I've actually picked type 2 diabetes 3 times here, so we've seen the 4th covariate is type 2 diabetes group condition anytime. Now the reason I'm doing this is because I want to show you how you can utilize the standard covariates in feature extraction and the analysis IDs for the feature extractions I showed you earlier. So these are going to have slightly different analysis IDs, and I'll explain to you how they differ when we're constructing these features in the next slide, on the next tab, when I'm going to be showing you the covariate table. But here, this effectively tells you what your model is. So this is a very nice way of just representing an existing model. So you've got the covariate name, and each name has to have a unique ID, and then the coefficient value. Now, you need to also define what those model covariates actually are. So if we look at the covariate table, we see now for each model covariate ID here, we have at least one row for that model covariate, but we can have multiple rows. So what this is saying is that for model ID 1, which is age 50-54, we're looking for a covariate ID of 10003. Now this corresponds to the feature extraction standard covariate of age 50 to 54. And the way you can work out these standard group age groups, standard covariate group age, is it always has analysis 3, and the first age group is at 0, and then as you go up in 5 intervals of 5, you get a concept idea of increasing. So this is effectively the 10th age group, 5 age group bucket, which means this starts at 50. So we see here. But then for model covariate ID 2, which was the type 2 diabetes condition occurrence long term, I've actually got 2 rows here. So I've got 2 concept IDs. I have a concept ID that effectively corresponds to type 2 diabetes condition, and I have a concept ID that corresponds to complications due to type 2 diabetes. So this and these are actually independent concept IDs. So I wanted to define type 2 diabetes with both of these, just like you would with a concept set. You can have multiple concept IDs to define a concept set. Here we've got multiple concept IDs paired with an analysis ID for a covariate, a model covariate. So now we've got a concept ID, but we also need the analysis ID that will give us a standard covariate that we can then combine into our model covariate. So because we're looking for condition occurrence long term, we're going to use the analysis 102. So this is saying that we're looking long term because it's 102, and it's going to be the condition occurrence. So what this means is that when we're looking in the database, we're going to look at people who have this concept ID in the long-term period that we're looking back, or this concept ID in the long-term period that we're looking back. But we're not going to be looking at descendants of these concept IDs. So for someone to have model covariate 2, which we've called diabetes condition occurrence long term, the way we're defining it is we're saying they have to have this concept ID or this concept ID in the long-term look-back period prior to your cohort start date. Now, for the third covariate, model covariate, which was type 2 diabetes group condition long term, it's going to be similar to the last one. We're going to have, again, the type 2 diabetes concept ID, complications due to type 2 diabetes concept ID, but this time we're using the analysis ID 210, which is saying it's a long-term condition group. So this means we're looking at people who have this concept ID or any descendant of this concept ID, or so people who have this concept ID and any descendant of this concept ID in the long-term look-back. So there's actually going to be more people who have model covariate 3 than have model covariate 2, assuming that there is some child of these concept IDs that doesn't just map to the parent. And then the final one that I want to show you is we're going to be looking at type 2 diabetes group condition anytime. So now this is going to be similar to what we just had here, where we're looking for people who have this concept ID or any descendant, people who have this concept ID or any descendant, but because we're looking at anytime condition group, it's going to be people who have this anytime prior, so it could go further than the long-term look back. So this is how you can construct existing models. So you have to have some name or model ID, and then for each model ID you need to give it a list of the standard covariate IDs, like one or more covariate IDs that are going to basically be grouped together into that model covariate. And this is found by having a concept ID and the analysis ID. Now you need to be careful because not every concept ID can be paired with an analysis ID. If you have a very broad concept ID, they generally won't exist in some of the groupings. So if you've got a very complex definition for a covariate that you want to construct, it might be better to actually have a concept set, and then for each you can actually export that concept set from Atlas into an Excel sheet, and then append the analysis ID for the condition occurrence or the drug exposure onto those each of those of the concepts you have in the concept set, and then you can just put that into R into this table, or you can create a table like this in Excel and just load it into R. So sometimes that you can get this is quite complex to do. You can see examples in the prediction comparison study package that we have in OHDSI, where we've done some existing bleed and stroke models in this format if you want to see how it's done. And sometimes a model covariate could have 50 different covariate IDs. Sometimes you might need custom covariates as well, and that's possible to add, but I'm not going to show in this example. So once you've got these two tables, the only remaining table is the intercept table. So sometimes models have an intercept. If your model has an intercept, you can add it by using this data frame model ID. We're using 1 again because we've always got model 1, and then we have this intercept value of 0. But if you had an intercept of 10, you could put this as 10. If you don't actually have, if your intercept is value 0, you can actually just ignore this and put null in for your intercept table. But I wanted to show you what this is in case you do have an intercept. So then the final thing that you need to be wary of is that you've created in your covariate table, you've said, okay, for this model covariate, we have these sets of standard covariate IDs. And these standard covariate IDs have used some analysis ID. Now, by default, long-term look-back will be 365 days, medium-term look-back will be 180 days, and short-term will be 30. But you might want to actually change that. You might be replicating a model that said, I want type 2 diabetes occurring in the last 400 days, in which case you can actually change your long-term start period to minus 400 in this covariate settings, and this is going to tell us when we're running this model we're going to have a long-term start date of 400. And also in this covariate setting model, you need to make sure you actually use every analysis ID that you've used in your covariate table. So we used analysis ID 3, which was age group. We used analysis ID 102, which was condition occurrence long-term. We used analysis ID 210, which was condition error long-term. And we used 29, which was condition error any time prior. So you need to make sure in this covariate settings you have every single one of those set to true if it's used in your covariate table. If you don't set these to true, but you've used them in the covariate table, they won't be included in your model, so you'll have an incorrect model. Because what effectively happens is we create the standard covariates first based on what you set here, and then we aggregate them based on the model table or the covariate table that you see here. These two covariate IDs get combined together for the model covariate ID 2. So you have to have this set correctly. And then you just use this evaluate existing model in the patient level prediction, where you're going to insert your model table, but you only want the 3 columns model ID, model covariate ID, and coefficient value. Then you want your covariate table, but you only want the columns model covariate ID and covariate ID. Then you have your intercept table if it's needed, otherwise you can set this to null or just ignore it. You want the type, so either logistical score. And then you need your covariate settings, and this is going to show us how we're actually defining some of the variables in the covariate settings, like the long-term look-back. Then you need your database settings as normal, so you need your connection detail, you need the string tells you the database schema for the CDM is, you need to know the database schema for the cohort, you need to know your cohort table. I'm just assuming we're using Atlas, so we're just using the cohort table, and then you need some cohort ID. And then you also need the outcome database schema. I'm assuming in this case it's the same, that would you be using Atlas, and we'd have a cohort for the outcome table, and we're going to have an outcome ID of 2. So this will look at, in this cohort table, in this database schema, it will find everyone who has a cohort definition of 2, and that's the outcome. And in this cohort table, in this schema, it's going to find everyone who has a cohort ID of 1. That's going to be our target population. And then you need the time at risk. So when are we looking for this outcome occurring relative to the cohort start date? Well, we've got a risk window start of 1, a risk window end of 365. So in this case, I'm looking within the following year. Again, you can set this to any time period you want. So if you're evaluating a model that looks for 10-year risk, you could actually say from 1 year to 3650. And then required time at risk, whether you want people to have this full time at risk. In this case, I'm saying I want them to have the whole time at risk. So I want them to have, I'm setting this to true, and I've set the min time at risk of 364, which is the whole time at risk period. Again, you can change this depending on the problem and the prediction you're actually trying to evaluate, what settings they used. And then do you want to include all outcomes? So this is saying you include the outcomes even if they don't have the complete time at risk. In this case, I'm saying true, but again, it depends on what you're trying to replicate. And then the last thing is this covariance summary option. So if you set this to true, when you run this, it's going to apply the model. You're going to get a predicted risk for each person returned. So it's going to be your population with the risk appended. And then you'll also have some summary statistics of how well the model performed. And you also get covariance summary. So you'll see for people who have the outcome, how often each of the model covariates that you have occurred, and how often it occurred in people who didn't have the outcome. And this might tell you that you've made some error in your covariate table. So if you made some mistake here, so you've got an incorrect covariate ID, which is meaning your model covariate ID is wrong, you'll generally see it when you look at the covariate summary from this result. But if we run this now, this is going to create the model where it's saying if you are aged 50 to 54, you have which is defined correctly, you have a coefficient of a value of score of at least 1. And then if you have diabetes in the last 400 days, because I set long term to 400 days, so if you have any of these two concept IDs in the 400 days prior to your cohort start, you'll have a +1 on your score. And then if you have these or their descendants, these two concept IDs or their, so this one, or any descendant in the last 400 days, then you'll have a plus 0.5 to your score. And if you have this concept ID or this concept ID plus any descendant ever before your cohort start date, then you'll have plus 0.5 to your score. And then that's your total score is your risk. So that's the simple model that we've created here.